Hello and welcome to the complementing video number 1.1 of our video series about graphical programming with test.con 6 Studio. After publishing the first part of our video series, users have suggested to give more basic information about the programming system. In order to keep the information flow of the actual tutorial, we decided to use sub-pagination for our videos. In video 1.1, I will show you the basic programming components of the programming system test.con 6 Studio. On the screen you can see the system context diagram, which you already know from previous videos. The system context diagram is part of the configuration level. Such a configuration can only exist once in a test.con application. It represents the so-called application root. Further programming elements are the program block, macro block and function block. The function block executes the actual functionality on the target system, the controller. The function block is the smallest executable element and was programmed in the system programming language C. It is available on the controller as executable code and it can be called any number of times. Further elements are the so-called visualization blocks. These blocks do not have executable code on the target controller, but they are used to visualize program variables and signal values. Furthermore, there are control elements, as for example a button or a slider. These are also elements which do not have any functionality in the controller. These elements are only used to generate signals for test purposes or to execute control actions. There are also the so-called standard macro elements, like for example the text comment or the pin block. The pin block is used as a breakpoint for the variable attributes. Furthermore, there are the inputs and outputs of macro blocks, because they must also have inputs and output in order to communicate with other blocks. Those are the blocks which you can see here in the library: macro, input, output, enable. You can also find the enable block. This one is used to temporarily turn off or turn on macro blocks during program processing. Now I will go back to the configuration level. In the configuration level, only blocks of the type program block can be implemented. When trying to implement other blocks, the program system will reject the attempt. Program blocks are special blocks with the functionality or the characteristic of a task. In the real-time application, only one program block exists. This program block is called synchronously or in context of data acquisition of the operating system of the controller. Theoretically, I can implement more than one program block into another application. I could implement up to 15 program blocks. However, that does not work in real-time task. There I can only implement one program block. In the system context diagram, only this program block is a programming element in test.con. All other elements shown here are only there for documentation purposes and are part of the background image. In design mode, I can assign such a background image to a configuration. I have changed the configuration and I can now assign a background image. Here I can use bitmaps or vector graphics formatted in EMF. A very important programming element are the macro blocks. Macro blocks are interconnections of available function and macro blocks to blocks with higher or more complex functionality, which can be reused by the application any number of times. Such macro blocks can be reused in other projects or can be provided for other programmers too. Now I will create such a macro block. For that matter, I will create a new folder with the name My Folder. Here I will create a macro block called My Macro. A new worksheet has been created. On this worksheet, the block diagram for this block can be drawn. I will use very simple function blocks for that. This is the logic function block AND. When implementing the block, I am immediately asked to define the number of inputs. I will leave the 2 inputs. For the example, I will negate one of the inputs. Additionally, I will implement an OR block. For this block, I'm also asked how many inputs the block should have and if I want to negate any inputs or outputs. I will not do that for now. I'm connecting both blocks and implement macro input and output blocks. Here I can assign the name and the data type of the input, but I do not have to do it right now. I'm connecting the block. It is possible to copy the function block over the common Windows shortcuts Ctrl+C and Ctrl+V. Sometimes it is faster than to drag it from the function block library. I will implement another block like this one. The input names will number consecutively automatically. I am connecting input in3 with the OR block, and I am also implementing an output block. I could type a name here again, but I will leave it like that. Now I will connect the 2 blocks with each other. In design mode, I can give this block a new look. In this mode, I can define whether the designations of the input and outputs should be inside or outside the block. Furthermore, I can set the position of the inputs and outputs according to my wishes and needs. I can also assign customized bitmaps and vector graphics. I will leave the look of the block like that though. I can now reuse such a macro block in other program blocks too. Now I will drag the macro block into the worksheet of the program block. In the next complementing video, I will explain the operating modes edit and run a little more. I will especially talk about the differences of these operating modes. I hope I will welcome you in part 1.2 again. Thank you very much.